Okay, let's get started. It's cool to see that many people in here. I was like, up until about a few minutes ago, there were like a few people here, but it's actually quite cool to see that many people who wants to get away from JavaScript. I would kind of expect it to get the big room one if it was to talk about getting away from JavaScript, but apparently I get one of these. So the talk is about TypeScript, JavaScript for C# developers, and that's quite pretty much what it's going to be. So my name is Klug. I work as a software developer / mentor / speaker / basically whatever you pay me to do within IT. I will do. I work at a company called Novatrox. It used to be Novatrox Consulting. It's renamed. I'm at a new company called Novatrox Division, where I basically go around building stuff and telling other people how to build stuff, which is much more fun than actually building it yourself, because you can blame other people. So the talk is about TypeScript or JavaScript that scales, which is what it says, I think, on the TypeScript website. So TypeScript is, according to the TypeScript website, which is typescriptlang.org, says TypeScript is a typed superset of JavaScript that compiles to plain JavaScript. Okay. It's actually pretty spot on for obvious reasons. It's on that website. But what we get is this. So you have that little core of JavaScript or ECMAScript 3, which every single browser and pretty much your hairdryer will support. Then you've got ECMAScript 5, which is what most browsers support the biggest part of. And then you got ECMAScript 6, which is new stuff. And then you got other new stuff that's going to come in the future. The cool thing with JavaScript is that very little happened for a very long time. And then all of a sudden, a whole heap of things happened in a very short amount of time. And now they're looking at like 3 versions ahead. Sometime in 2097, we're going to have this feature. And they're already talking about it. So what TypeScript does is that it actually takes pretty much all of everything that's in JavaScript 3 and 5 and 6 and features that are coming in the future are in TypeScript as well. So whenever they start looking at getting the spec for JavaScript done, before the browsers start supporting those features, if it's possible to build them into TypeScript and have it transpiled into some weird version of that really works in an old JavaScript environment as well, you will get that feature. So with TypeScript, you'll always be working on the kind of the latest and the greatest. But in the end, you're going to compile it down or transpile it down to JavaScript that runs in the browser. But we also get a few other features. We get object orientation. So we get classes and interfaces. Classes are coming in JavaScript or ECMAScript. It's just no browser will support it at the moment, but with TypeScript, we get it. We get static typing. Static typing is frickin' awesome. I'll come back to why. And finally, we get typings, which is, it's not really a TypeScript thing, but we get separate TypeScript files that only include definitions. So basically, they only include interfaces, but it means that JavaScript libraries that weren't built in TypeScript can still be used from TypeScript, and we can still get IntelliSense. We can still get typing. We can still get all that static stuff that we want from TypeScript, even though it's a pure JavaScript library. So there are typing files for most big JavaScript libraries out there. So if you're doing jQuery, jQuery is written in JavaScript, but there are typings files in TypeScript that makes it possible for you to integrate with jQuery using TypeScript in a nice way. So why is static typing a big deal? Well, is it a big deal? Yes, it's a huge deal. It's the main reason for going to TypeScript in my world. It gives you tooling. It's kind of impossible to give you good tooling without a statically typed language. But Chris, if I go into TypeScript or into Visual Studio and I open a JavaScript file and I write something, I press dot, I get IntelliSense. It opens up a drop-down, right? Right? Have any of you ever seen Visual Studio? It opens up this little thing. That is not IntelliSense. That is a box in which Microsoft takes every single string it has ever seen you type, ever, in a drop-down and goes, you might want to use one of these. And then it sort of invents a few strings as well, not things you've never written. They will be in that drop-down as well. With static typing, we can get proper IntelliSense, we can get proper feedback from Visual Studio of what's available or not. So we get real IntelliSense with our tooling with static typing. We get squigglies. Never underestimate the squigglies. If you get squigglies, you're doing it wrong. Squigglies are awesome. You get code navigation. You can put your marker on a piece of code and press F12 and it will jump to that implementation inside of TypeScript as well. Ever tried doing that in JavaScript? Not a fun experience. The way you find something in a big JavaScript program is you press Control-Shift-F, which is basically find all, and then you write some weird, awesome, regular expression that fits into what you're searching for, and it gives you 90,000 files back. And it goes, do you want to look inside the source code of jQuery? Nope. This will give you proper code navigation. It will give you productivity. Okay. Productivity was not high on your list, it's high on my list, because my clients pay me per minute. Actually, it's per hour. But they want me out of there as fast as possible, so they're happy if I'm productive. And it also reduces my errors. There are very few pieces of technology that I will say straight up will reduce errors in your code, but in this case, if we compare it to JavaScript, with static typing, you don't end up passing in a number when it was supposed to be a string, or you pass in a boolean that is then converted to a string and returned as a number and things like that, which kind of happens in JavaScript. So that gets reduced and removed in this case. And in the end, we get maintainability. I have actually gone to the point where I have canceled a contract with a client because they would not switch from JavaScript to TypeScript. Because they were building a huge system, it had a lifespan of at least 10 years, and they were writing everything in JavaScript, and about 4 weeks into the project, it was more or less impossible to maintain it because it was so hard to figure out what was happening, and there was only one guy that knew what it was actually doing. TypeScript will remove that and make it much, much easier for us to maintain a system in the long run, according to me. So how do we install this thing? Well, if you're in Visual Studio 2013 before Update 2, you won't have it. You will also have a very old environment you're working in, so you might want to update it. So if you get past Update 2 of 2013, you get it. If you have Visual Studio 2015, you have it. If you have Visual Studio Code, you will have it. If you have Rider, I think you'll have it. You'll basically have it in every IDE that you download and install. And if you're not doing an IDE, you want to write all of your stuff in Notepad and compile it on your command line, you can just use npm to install it on your machine and you're good to go. One thing to note, though, is that I am using the latest version of TypeScript, version 2, and some of the features I show might not work unless you update the installation in Visual Studio. So you need to install the extension for Visual Studio with the 2.0 version for it to work. But that's easy to do. Syntax. I will show you code, I promise. I will actually do a code demo, but I want to show syntax in an easy-to-do, like, PowerPoint way first to focus on the syntax, and then we can write something. So, first of all, the types that we've got. Pretty much what we'd expect to have. The only thing on the left column there that we don't know is any. That's not available in C#. Any means, JavaScript variable. You can do whatever you want. I don't care. Put things in it. Take things away. You can literally delete properties on it if you want to and things like that. String, fine. Boolean, fine. Number, yeah, there's nothing like integers and things like that. Int 16 and int 32 and int 64, there's a number. That's it. JavaScript only has floats. We've got arrays, which you can have two syntaxes of. You've got the bracket, which is JavaScript notation, and you've got the array of T, which is the generic TypeScript version of array. We've got tuples, we've got enumerations, we've got nullable types. So you just go with the type and a question mark, and it's nullable. We have return values. We have void. I'm not returning anything. We have null. I'm returning something else, but it's not something, but it's not nothing. Makes sense, right? And then we can return undefined, which is kind of like null, but not null, but it kind of means nothing, but is still something. Don't ask. And we've got never, which is a new one. I love returning never. You can it's actually what it says. It's a function that never returns. So if you do a while true inside of it, you can have a return type of never. If you always throw an exception inside of your function, you can have a never. If you write a function that always throws, you've got issues. So I've never actually used never, but I find it funny to have. And we've got classes and we've got interfaces. So it's pretty much our standard C# that we're used to, but TypeScript. We've got namespaces. That looks pretty familiar, right? Namespaces are kind of going away. I will come back to that later on. Namespaces are kind of leaving TypeScript a little bit because of JavaScript modules, but we'll look at that at the end. We've got classes. Sweet. We export classes. Namespaces in TypeScript are actually containers. And anything inside of a namespace is not visible outside of the namespace unless you export it. So everything is private inside of the namespace. We have constructors, named a little bit different than C#. We have constructor parameters. And as you see, the types are then noted as colon and type instead of having it before. So instead of string first name, it's first name colon string. Not very complicated. We have private members, which is awesome. Because JavaScript generally goes, you want to have it private, just use underscore of the variable and all of the developers around you will know that it's a private variable that you shouldn't touch. Very private. We have public members. This is something that irks me as a C# developer because everybody has forced down my throat my entire life that we should never just have public strings in our classes. We should have properties with getters and setters. We do a whole lot of public members in TypeScript. That's just, it happens. We've got shorthand members, which is really cool. It's a feature that I think is available in C#, some version. You can just put public, or it's coming in C#, I think. You just put public in front of your constructor parameter, and it becomes a public member of that class. So we don't have to go ahead and have a member in our class, and then in our constructor say this dot first name equals first name, this dot last name equals last name. We just go and say public, and all of a sudden our members are public in our class. Works as well with private and protected as well. We have properties, so if you do want to go with full-blown properties, we can do that. We just do get and set. They're functions, both of them, so not very complicated to do. We have, obviously, functions. By default, everything in TypeScript is public. Everything in C# is by default private, so you have to keep that in mind. We have function parameters. If you look at the do something else, y equals 2, we have default values as well for optional parameters. We can add a nullable parameter, which basically means it's an optional parameter that you don't have to pass in. We do have function overloading and things like that as well. We have arrow functions, or lambdas. These are awesome, and I will come back to why they're awesome later on. My main recommendation is whenever you write a function in like a callback or something like that in TypeScript, always use a lambda expression. Don't write function e curly brace. Use the fat arrow thing instead, or the arrow function. They do actually work differently. This thing will work as you expect it to. A JavaScript function will not work as you expect it to. As I said, I'll come back to why. Just keep in mind, always do arrow functions if you can. We have delegates, which is quite obvious because JavaScript is a language built on functions. So being able to have delegates that we can pass around and things like that is fine. So here we have a fn member, which is of type. The type is inline there. So basically it says it's a function that takes 2 strings and returns a string. And then we assign it to a function, which is basically an arrow function or a lambda expression. And then we can execute it at the bottom. We have enums, or enums. Enums are awesome. Very simple. We can just go, I have a color, and do the names of them like we would do in C#. We can give them numbers. So we can define that red is 1 and green is 2 or whatever. And we can even have small calculations to calculate which value it should have and things like that. And whenever you use an enum, it actually converts it into a little dictionary as well. So you can go color.red will give you, actually in JavaScript, it will give you the number. But then you can use the color and index and basically say, can I get the string version of this number? So it's a little bit different than C# in that respect. We have casting. which you'd expect. It's a statically typed language. We do have to change types once in a while. So in this case, we bring out a element by ID from our document, and then we cast it to an HTML button element, but the casting is done using less than and greater than signs instead of using parentheses. We have generics. Everybody loves generics, right? Generics are in there a whole lot and makes a lot of sense to use. So you will see a lot of generics going on when you do your TypeScript stuff. We have inheritance. Inheritance works exactly as you expect it to do according to C#. The main difference is we use extends instead of just colon. And to call our parent class, or the inherited class, we use super. So if you want to call your base class's constructor, you do super, and then you pass in the parameters that needs to be passed on to the base class. Super has to be the first call as well in your constructor. We can do interfaces. Cool thing with interfaces here is that they're actually a lot more flexible than C# interfaces. The I do stuff is what you'd expect. It's an interface. It declares to one method called do stuff. It takes a couple of parameters, returns a string. The second one is just, it says it has to have a property of type string. And then on our class, we can say that class that does stuff implements I do stuff. Pretty much C#. But we can also go ahead, as we do in that thing at the bottom here, and actually inline our interfaces and say, basically, I want to have a function here that takes a parameter called vals, and that parameter has to fulfill that interface. It has to have an X property and a Y property, and they should both be numbers. So we just inline it here. I don't have to declare a specific interface. I just inline the type and say, this is what I need. Give me one of those. That brings us to the fact that interfaces in TypeScript are actually structural. They're not real interfaces like we'd expect in C#, where when you pass in an object into a method that expects an interface, it looks as well if you have actually implemented that interface. Instead, TypeScript looks at whatever you're passing in and makes sure that that object actually fulfills the interface, whether or not it says implements interface. As long as it has the correct members, it's happy. So in this case, I declare I values, which basically has an X and a Y. I have a function that takes an I values. But if you look down here, I am more than happily allowed to pass in a new my values, which is a class, which doesn't actually implement that interface at all. It doesn't say implements I values. But I values says that it has to have an X property and a Y property of type number, and my values does have that. So it's going to be happy to let me pass that in. I can also do an inline one. I can do an object literal and basically just go curly brace, x1, y2, and it's going to go, okay, he needed an interface with those properties. That's what you're passing in. I'm happy. So we do a bunch of quite funky things that I kind of miss when I go back to C#, to be perfectly honest, because C# is just a little bit stricter. The thing to note about interfaces, though, when you transpile your TypeScript to JavaScript, your interfaces goes poof and disappear. They are only structures that work within TypeScript. They are never transpiled into anything else in the JavaScript world. As soon as you transpile, they go away. And modules. This is the reason why I'm saying that namespaces are kind of going away. Namespaces in C# kind of make sense because we take all of these different files that all declare that members in a different namespace, and they get compiled into an assembly, right? And then we deploy that assembly, right? Have you seen C#? Yes, that's the way it works. In JavaScript, or in TypeScript, if we declare namespaces and we transpile it, we don't get a unit. We actually get every single file gets individually transpiled into JavaScript, and every single individual file will have stuff that goes into that namespace. So what is actually in that namespace depends on what JavaScript files you are loading into your web page, which is a little bit weird. So basically, I know that in this namespace I have these things. Oh, I don't because I forgot to load that one file, but that other file still has my namespace. And also, there is no connection in TypeScript that says this file over here that declares something in namespace X actually belongs together with this file over here that also declares stuff in namespace X. They are completely different things. They just happen to declare things in the same namespace. Modules is a JavaScript notion, and it's straight out of JavaScript. So it's not a TypeScript-specific thing at all, but it allows us to say in one file that I am dependent on another module, and a module is basically a file. So I can say here, I want to import the definition of my other class from a file that's located in /, basically same folder as I am, and it's going to be named myother.ts, but we remove the .ts at the end. We can also go ahead and say, I want to import the definition of a magic class from my magic framework. My magic framework, in turn, is then not a file on disk. It's probably something I've downloaded off of NPM and used from the Node repo. And then the IDE has to be smart enough, or rather TypeScript transpiler has to be smart enough to figure out that my magic framework actually refers to this thing over here, so I need to make sure that I get that definition, yada, yada, yada. But it's a way for us to actually link files and modules together so that when we build it, we can then go ahead and say, can you please load this thing here? And it will figure out all of the other dependencies and all of the other files that needs to be included for everything to work, instead of that old JavaScript mishmash that we used to have, which is for every JavaScript file I generate, I add a script tag on my page, and if they end up in the wrong order, tough, your application goes poof. This will sort that out. So a module kind of replaces the idea of a namespace, and just as with namespaces, anything that needs to be exposed outside of that module needs to have an export keyword on it. Any questions on syntax? Kind of similar to C#, right? Ish, at least. Okay, transpile, compile. I call it transpile because I don't find that it does a proper compile, but it's called either or. You can transpile/compile your TypeScript to JavaScript using a bunch of different tools. Visual Studio will do it for you automatically. So if you add a TypeScript file, Visual Studio will transpile it to JavaScript for you. You can use tsc.exe, which is the TypeScript compiler. It will do it for you. You can use gulp, grunt. You can use some Node stuff. You can use a whole heap of different things to do the transpilation. It's up to you. Just one thing that I want to say is, do not check in your transpiled Java files into source control. At least I don't. I check in my TypeScript file, and as part of my build, I will generate my JavaScript files and bundle them and minify them and all of that. I don't check all of that stuff in. Code. Let's do some code and see what we can actually do. So I have a Visual Studio here with it's a ASP.NET Core project. Obviously, we have to run core. The reason that I'm running core is that it's that much code to get my web server up and running. It just serves static files, and it says that the default file to serve is index.html. And if I go in and have a look at the www root index.html, it's an HTML file. It has an input, a button, and a UL. So if I run this, it builds, maybe. It runs, and it's beautiful. Nope. I was supposed to be an art director. I ended up being a coder. So what I'm going to do is I'm going to build a little Spotify searcher. Anyone who's ever seen me before knows that I love doing stuff with Spotify because their API is open and very, very simple to work with. So I'm going to go here into my scripts folder, and I'm going to go ahead and I'm going to add a new TypeScript file. So add new item, TypeScript file, and I'm going to call it app.ts. In here, I'm going to say window dot, look at that, IntelliSense, proper IntelliSense. On load. Can everybody see what I'm typing? Well, you can at least see what I'm typing. The IntelliSense might be a little bit blurry, but so on load is what I want to use. I'm going to say that that is a function, like that. Inside window.onload, I want to go ahead and I want to pull out my resources from my page. So I'm going to say let's pull out my query text box. equals document dot get element by ID. Once again, TypeScript gives me IntelliSense. That's what you want to take out of this presentation. I'm going to pull out my query text box. I'm going to go ahead and say, copy a couple of those. I'm going to pull out my search button, like that. I'm going to pull out my UL, like that. That didn't work, like that. So I get all my resources. The cool thing now is that these are actually typed. So this, it might not be seen visible in the back, but it does say that this is an HTML element. And I can cast these into different types of element and stuff like that. So what I want to do is I want to hook up my click event on my button. So I'm going to go search button dot on click equals lambda function, like that. And then in here, I'm going to take and pull out my query. So I'm going to say let query equals query text box dot value doesn't exist, right? I got dot node value and node type and a bunch of that, but nothing that says value. Reason? My query text box is an HTML element. HTML elements do not have a value property. Only input elements do. So this is typed, so I'm just going to go in and say HTML input element. It's casted over to an HTML input element, and all of a sudden I get IntelliSense that corresponds to being an input element, and there's a value property on it. And if I look at it, it says that it's a string. Then we can say if query, if not query, return. We'll come back to that a little bit later, but JavaScript has a weird truthy, falsy kind of thing. It doesn't have true and false. So this thing will basically say if not query, and that means that if the query is empty or null or undefined or a bunch of other things, it will just be false. Sorry, false-y. Yes, it's weird. It's JavaScript. In the end, it's still JavaScript, right? We get some stuff from TypeScript, but it's still JavaScript in the base of it. So we do get some of the JavaScript features. Let's call them features. Quirks is another useful one. So I'm going to just go console.log just to see that this works. I want to log out query like that. So next up, I need to go to my index file. As you can see here, my JavaScript file is available now because Visual Studio has already transpiled it for me. It has figured out that I have a TypeScript file, and this is what it transpiles it into, which is very, very similar to my TypeScript, but it's not TypeScript. I pull that in down here, save, go out here, press F5, pull up the little console. I go in here and I search for iron, and there it is. It says iron. Okay, that didn't work. I just want to take it slow, so step by step to see that everything works so I don't screw up along the way. So I know that. I can use my UI. Next step is I want to do some Spotify stuff. So I'm going to go ahead and I'm going to add a Spotify searcher class. So let's go add, new item, TypeScript file, Spotify searcher, like that. And inside this file, I'm actually going to use a namespace, just to show you how namespaces work. So we're going to do namespace space TypeScript.demo, like that, just like we would in C#. And in here we say export class Spotify searcher, like that. Anybody not following this? Good, because if you're not following what I'm doing right now, another profession. Sorry, search artist, it's not complicated yet. It won't actually get very complicated, so you'll be fine. Search artists is my method that I want to have. It's going to take a query, which is going to be of type string, and it's going to return a promise of type any, like that. So two things here. First of all, I don't actually have to explicitly tell a function what it returns, because TypeScript will actually figure out that if I inside this function return a promise, it will figure out the return value on its own. So I don't have to do it. But I'll do it here because it's simple. And it proves a point. This is the point. It will now give me squigglies. it's going to tell me, if I hover over here, it says cannot find name promise. The promise JavaScript library is not part of the standard stuff in TypeScript, because it's not available in every single browser. So TypeScript will only pull in, by default, things that is available in all browsers. So what we have to do is we have to tell TypeScript that, by the way, I know that this thing is going to run in Chrome. So I know that with Chrome, promise is available. Just give it to me. Stop being a bitch. The way to do that is you go to your project and you go add new item. You go to TypeScript JSON configuration file. It has to be called tsconfig.json. And you get this thing here that tells TypeScript how to do its transpilation. We can add a bunch of configuration in here. The only thing I'm interested in is removing that. And I want to say lib. Not there. I want to say lib. And then I can tell it what libraries I want it to load while doing the transpilation. So I wanted to use the DOM, and I want to use ECMAScript 2015. So please load all of those things for me, so that I can work with those features. And then a little while later, it goes green, and everything is fine. And then it goes red again. It goes red because I'm not actually returning anything. So it's saying here that a function whose declared type is neither void nor any must return a value. Sweet. I need to return something. Fine. I'll do that. So what I'll do in here is I'm going to run off to Spotify and do a web request. I'm going to use a feature called fetch. Fetch is an API in Chrome and future browsers that will allow me to do an HTML request or HTTP request. Problem number 2 here, it gives me squiggly lines again. It's telling me cannot find name fetch. Fetch is not available in all browsers, ergo not available in TypeScript. So there are 2 ways to solve that. I can either go up here and I can say declare var fetch any. And that's telling TypeScript that, dude, there will be a variable called fetch when this thing runs. I know it. You don't have to know it. You as a transpiler just have to realize that there will be something called fetch, and it's of type any, and I can do whatever I want with it. And then I can go ahead and I can say fetch, and I can go away and I can fetch the URL, and then I happen to know that it's a promise that comes back, so I'll write this. Response, and that takes one of these. It's kind of annoying, though, that I'm not getting IntelliSense, right? Because one of the things with TypeScript is I want IntelliSense. I can solve that, not in the same way that I did before. I can't go to TypeScript, to the config file, and say, can you please add fetch stuff, because TypeScript doesn't know what fetch is. But I can do this. I can go to my folder, open the command line. That's not very visible at the back, I assume, so let's make you all seasick by flying around my screen. And in here I can write npm install @types, which is a NuGet module where they have typings for TypeScript. @types / and let's see, what -fetch. Obviously. You obviously Googled this. You don't know these things by heart. Trust me, I Googled it. And that installs 2 things. It installs typings for fetch and for streams, which is another typing file it needs to run. That, in turn, if we look inside Visual Studio, adds a node modules folder in which it adds an @types, in which it adds these, in which it adds a TypeScript file called index.d.ts. And if we look at that, it's basically a TypeScript file that only includes interfaces that defines what fetch actually does, what the API for fetch is. The cool thing is that now this complains and goes, cannot declare block scoped variable fetch. Nope. I can't, because Visual Studio has already looked into the @types folder, located the index.ts file, figured out that there is something called fetch available, and now it gives me IntelliSense. Sweet. So what I need now is I need to tell it what to go and fetch. So let's head over to Spotify, which is like one of the best things Sweden has ever produced. Way, way, way ahead of ABBA. So I'm going to pull out this URL here, because that's what I use to search for an artist. So I'm going to go in here, and I'm going to switch these things here for backticks. What the hell is a backtick? Backtick is the key that you have next to your backspace, so you go shift and that key twice, it gives you 2 backticks. Backticks will allow you to have line breaks inside of your strings, and it will also allow you to do string that's really hard to say when you're from Sweden. Interpolation, something like that, like we do in C#. So I can go in here and I can say $, curly brace, encode URI, and all of a sudden I'm doing JavaScript inside my string. And I want to encode the query as a URI parameter and insert into my, my query. And then it has some issues with coloring, and then it goes in like that. So this should now give me all I need to do my request. What I don't like is I get JSON back, but we want typing. I want to know what I get back. So if I go in here and I look at the JSON that I get back, the sample they have here, which I can do that so you can see it. Whoops, there it is. It will give me back an object that has an artist property, which has an items property, which has a list of items for every single artist that I found, and inside that object I will find a name property and I will find an ID. So I know that those are the 2 properties that I'm interested in, and I know that they are going to come back from my JSON. So what I can do is I can in here say export, let's scroll, export interface, iArtist, like that. And I can say that it will have a property called ID, which is string. It's going to have a name, which is of type string. And I can now convert my function here to say, when you call me, I will return an array of iArtist. So I can type even my JSON that comes back from my web request and get that typed into whatever I need. I need to do a few more things here. This thing is not complaining. Yes, it's complaining like it should. I need to type this thing to say that it's of any. I need to say response dot, I happen to know that it's JSON that comes back, so I do that. And then I take this and I pipe that. This is now my JSON. So I get a response back, and then I tell the response that I want to get JSON out of it. And then I pipe that result into another promise. This is complicated stuff, I know. If you don't know JavaScript and JavaScript promises, it gets weird. Just trust me, this is the way you do it. So I get my JSON, and I say, I want to return JSON.artists.items, because that's what it's going to be. And when we read out items, which is this thing here, it will be an array of objects that happen to have an ID and a name, which is what I defined it as. Everyone okay with that? Sweet. So what we can do now is we can go back to our app.ts, and we can say here, somewhere around there, say let Spotify equals new TypeScript.demo.Spotify searcher. Look at that, IntelliSense all the way through. This thing, oops, Control C, there it is. Let's do dot IntelliSense search artists. What I want to search for, it asks for a query, so I'm going to pass in my query. And then it returns a promise, so I can go and say dot then. So when you're done, hard to see, but it actually says that you will get an array of iArtists back. So artists, and we'll do a callback function like this. Inside this, I can then go and say artists dot for each artist, like that. So basically it's a loop mechanism inside of JavaScript. And then we say let li equals document create element. So I want to create a new element, and it's going to be an li element. And this is awesome. This kind of took me by surprise when I tried this. If I go and say li, and I look at that thing, it has actually figured out that it is an HTML li element. So even though I'm passing in a string that says that create element can return any type of thing, if you're passing in li, TypeScript figures out that it will return an li version of that HTML li element. Okay, inner HTML, no, inner text equals artist. So artist is the currently iterating artist out of my artist array. So if I go and look at that, it will now give me IntelliSense telling me that there's a name property that I can pull out. And then finally we say result dot append child, and we append the li to get a result list out of what I've searched for. Make sense? There's a bug in this code right now. Right now, if I search many times, it will populate that li or that ul over and over again. So I'm just going to push this, say while result dot first child. There's something with my connection that makes it blink. Sorry about that. Result dot. This is getting ridiculous. Result dot delete. So now remove child. Result dot first child, like that. So that should basically just loop through until there are no more child elements to remove. You're kidding me. Okay, that works. I can't touch my computer anymore, but you can see the screen. If I go out now and I try running this, there's an interesting thing that comes up when I do this. If I go in and search for Brittany, I still guess just... Okay, I'll just keep going. I hope you can see most of it. It still just writes out Brittany down here. I rewrote this thing. This is different. It doesn't even have a console log anymore, and it's still just doing a console log. And the reason is that for some reason, I don't know why this happens in ASP.NET Core projects, but it doesn't recompile TypeScripts as you save them. That is easily fixed by going into tsconfig and down here say compile on save equals true. And then we go back and we compile the app.ts, and we go and we compile this thing. And also one more thing that I need to do is I need to add my Spotify searcher JavaScript file like that. If I go back out here and I search for Brittany. Okay. Iron Maiden, is that better? Let's search for Iron Maiden. I could go and search for ABBA. Yeah, exactly. We don't want to search for ABBA. That's very, very true. So that's actually kind of cool because I've got IntelliSense all the way through, and it might not look hard to write this or in JavaScript, but honestly, I would probably have made spelling mistakes and type mistakes and things like that going through this. I get all that help from Visual Studio. So what I want to do is I want to remove the namespace because I want to do modular loading instead. So by doing that, I'm going to go ahead and I'm going to say, or to do that, I'm going to go and say, I don't want namespaces anymore. Like that. So now this is a module. So my Spotify search.ts is now the module, and that module exports a class and an interface. That's all I have to do to change it into a module. Then I go into my app.ts, and I go up here, and this is now complaining, because there's no such namespace. So I'm going to go in here and say import, curly brace, from, and then we do ./Spotify searcher. And then we go back here, and we press Control space. If you go home and do that, it's going to take a little while. When I present, I got time for it to load. So from the time when you write the last R in Spotify searcher, it takes a little while before Visual Studio actually catches it. So you might have to go back and then go Control space and then hammer it for about 10 seconds, and then it gives you IntelliSense. So if you see me up here frantically killing my keyboard, that is what I'm actually doing. I am coding. Now that I've got that, I'm basically saying, can you please import the class Spotify searcher from that module? And then down here, I basically just say, can you go and create a new instance of that class for me to use? The cool thing now is that since I have references between my files now, I can use a module loader. We're going to make one more change. I need to remove that because I won't have a window.onload anymore. Whoops. Because this module here, my app.ts module, will be loaded dynamically. So it will be loaded after window.onload. So to do that, I'm going to go out to my index.html, and I'm going to remove these files. Like that. I'm going to pull out a little library here called system.js, which is a JavaScript module loader. There are a bunch of them available, but system.js is the one that I normally use. And then we say system.configure. Nope, config. Look at that, how nice it would have been to have done this in TypeScript instead, where we've got IntelliSense. Because this kind of sucks. Especially since base URL is capital URL. It should be like a capital U and lowercase RL, but that just goes poof. So we want to tell it that all of my files are in the scripts folder. Scripts, like that. We have to tell it system.default.js extensions equals true. That's just a little workaround for a little thing in TypeScript. And then we say system.import. And we tell it, can you please go and import the module app? The module loader will then go and say, cool, base URL scripts, you want app. I'm going to go and download app.js. It's going to look in app.js and figure out that it depends on a different module called Spotify Searcher. It goes and downloads the Spotify Searcher module and then loads them in the correct order. So in my page, I only load the system.js. I tell it where my files are, tell it what first initial file I want to load. And if we run this and we look into the network tab, you'll see down here in CSIC mode, that it actually goes and loads system.js, and then system.js goes and gets app.js, which then needs Spotify Searcher.js, and it figures out all of that for me. Whoop, that's really cool, Chris. Yes, I know. It's awesome when you've got like 4,000 files. When you've got 2 files like this, it's kind of useless. But I'm going to step it up one level. I'm going to go, because I really dislike the fact that my Spotify Searcher takes a dependency on fetch, because fetch is not going to be available if I'm not using Chrome. So what I want to do is I want to have my HTTP service as a service instead. So we're going to do and go and say a new item, TypeScript file, HTTP service.ts. We do export interface HTTP service. Like that. It's going to have a get method, which is generic. It's going to take a path, which is a string, and it's going to return a promise of type T. That's the interface that I want to implement. That's my HTTP interface. Then we go and say export class fetch HTTP service, which implements. This is completely unnecessary as such. You really don't have to write implements IHTTP service or anything. I just have to make sure that I implement it in my code. Having implements here will let IntelliSense tell me that I'm stupid, I'm missing a part of the implementation, which just helps. So I'm going to take this thing here, shove that in here, like that. I'm going to go over to my Spotify Searcher, and I'm going to copy that, like that. So basically, I've put it all out there. I'm going to change this so it's all encapsulated in here. So I'm going to say path instead, like that. So this thing will use fetch to run off. It will then take the response, convert it into JSON, and it will return the JSON back. Which then means that I can go in here in my Spotify Searcher, say import, curly brace, from ./HTTP service, like that. Go back, press Control space frantically, and pull in the HTTP service interface. Create a constructor. All of this is stuff we should be kind of used to when it comes to C#. So I need a constructor which is HTTP. It's going to be of type HTTP service, like that. And since I need it inside of my class, I'm just going to make it private, so that I can down here go and say this.http.get, and what I want is an any, and this is the path that I want to use. I can remove this thing, and this is now abstracted away, which means I can go to my app.ts. It's going to complain, squiggly line, saying that I'm stupid. So I'm going to go here and say I want to import from HTTP service, and there it is. It works. And then we pass in one of those instead. So now I've got a modular abstracted away HTTP service with interfaces and everything like we would have in C#. Cool, right? The last little party trick I want to show is one that I haven't actually used that much because it's a very late addition to TypeScript. But most people, or a lot of people, don't like the .then. Then is a JavaScript thing with promises. But cool enough is we actually have async stuff. So we can go up and we can make this function async. We can go and say let artists equal await. Just go and kill that, remove that, remove that. And we also have async await in JavaScript. So anything that returns a promise, we can just go and say async await and await that thing, and the transpiler will transpile our async awaits into an awaiter thingy that uses promises and figures everything out for us on the fly. So just a final thing, does this actually work? It loads all of the files, and that's one of the cool things about using System.js. It's I just added httpservice.ts and transpiled it, and added a reference to it in my file, and then System.js figures out that that thing is needed as well, so it downloads that on the fly for me, instead of me having to add another link statement or modify some build thingy somewhere. Does it work? Let's see. Metallica, because you guys didn't like ABBA. There it is. It still works. So that is actually kind of the demo that I have. I must say, having started with it, once you get your IntelliSense going and you get typing inside of this stuff, all of your front-end stuff gets so much easier to build. However, sorry, they were supposed to be called features, I think. We are still doing JavaScript. No, we're not. We're doing TypeScript. Yes, we are, but we're doing JavaScript. And JavaScript comes with features / quirks / completely messed up stuff. We don't get rid of those. They are still there, but they are managed a little bit better. For example, for in, we would expect this loop for x in my strings to output Chris and James, right? Nope, it outputs 0 and 1. Why does it do that? Because if we put in an object and go for x in my object, it will output name and age. It actually outputs the property names of the object that you tell it to iterate over. For of, on the other hand, that works as we expect it to. That's just a JavaScript syntax thingy. So for of is what we need in most cases. Scoping. Scoping is screwed up in JavaScript. Or it's not screwed up, it's just different. It's a feature, right? If we have a method that takes a callback that I pass in a callback and I execute it when something has happened, if I pass in a function like this, you would expect this to be an instance of my first class, right? Because the class I am in is called my first class, so when I pass in a function, I would expect this to still be this thing here. Nope. It is something else. Let's not go into what it is. It's just something else. It's not that class. However, if you do a lambda function or an arrow function, this is actually the right thing. This is messed up. Yes, it is. It is completely messed up, and it has to do with closures and complicated JavaScript stuff that takes a while to get your head around. If you always just go ahead and use arrow functions, you are sort of safe, because all of a sudden, scoping works as in C# and not as in JavaScript. Next, if you do this is something that's quite easy to do. You go and say, I have a callback. This is my callback. I pass in my function on my object. This is not my first class. This is that other thing. Why? Because I'm passing in this function, I'm not passing in a reference to this class that has the function. To solve this, you do an arrow function. So you pass in an arrow function that in turn uses this dot callback, and that works fine, because inside of our arrow function, this is the right thing. JavaScript is awesome. This is another one of those I love. I don't know if you noticed it, but I declared all of my variables using let and not var, like you would do in JavaScript. Let is a JavaScript syntax thing as well. But this is what you can do in JavaScript and in TypeScript. I can write a function that declares variable x inside of an if statement, and then outside of the if statement, I can log that x. However, at runtime, if I were to pass in do something false, it's going to go poof, because variable x is not declared. Awesome. We solved that by using, let instead. Let is the same thing as var. It declares a variable, but let uses block scoping, which is what we have in C#. Basically, it scopes it within the next, the curly braces one step up, whereas JavaScript scopes it to the function upwards. So using let will remove some of that problems, and TypeScript will then tell you you are a nutcase, that's not possible to do. And then you have to fix it. So use let instead of var. Truthy and falsy. You would think a language would have a sense of true and false. Nope. JavaScript has its truthy or falsy. I'm so introducing that at home for my wife. Nope. That's kind of not true, but kind of, yeah. So the deal is that anything that is false, 0, empty string, null, undefined, or not a number is considered falsy. If it's not in that list of things, it's truthy. Yes, please. That is awesome. It means that we can do things like if my object, and that will then verify, instead of having to write if my object is not equal to null, do this, I can just go if my object. I can go and do myArray.length, which is awesome. I can also do myArray .length, and that will go and say, if my array is not defined, then do this. If my array is defined and there's nothing in it, then do this. So we have a bunch of other scenarios we can do with if statements based on truthy and falsy. And we can also add exclamation mark. Exclamation mark will take a truthy statement and make it false, true false, like a Boolean false. So if we do exclamation mark, we take a truthy value, we turn it into false, and then we turn it back to true. So exclamation mark takes a truthy or falsy value and turning it into its bool equivalent. You can add a third exclamation mark also, but it doesn't actually make any sense. Also, one thing to notice, everything is a dictionary. So if I have a string here called s, I can go and say s.length and pull out the property length, but I can also go and use a dictionary indexer to it. So basically every object that we create, no matter what type of object it is, it will always have an indexer that you can pass in a string to and ask to get the value of that property. Which means that property values that you can't actually use, things like property values with spaces in the name and weird characters and stuff like that, they cannot be used using the dot notation, but you can use them using the index notation. That's fine. So you can go ahead. I get the question once in a while, how do I do a dictionary in JavaScript? You create an object, it's a dictionary, you're done. So that's worth having in mind, because once in a while you end up in TypeScript and it tells you that property is not available. I know because the interface says so, but I know it's there. And then you can get around TypeScript by using the indexer notation instead, and it works fine. Thank you. It's been awesome having you here. I hope you got something out of my TypeScript presentation. Any questions? That thing just went red, like now. The best timed presentation ever. Yeah, I'm scared of letting you ask me let you ask me a question.
It's a super simple question.
Okay, in that case.
Go back to the slide. Can it figure out the type of link to? Is that
No, it's an any. Well, actually, It does have some logic. I haven't figured out really how it works, but in some cases, certain objects, when you do that, in this case, it would figure out the length, I think. Because in this case, it knows that string is a string, or S is a string, and then it looks at the variable you pass in, and then it basically goes and figures it out based on that. So if it knows that the type that you're using, in this case string, has a length, I think it returns a number. But if you're doing it for something that TypeScript doesn't figure out, it doesn't know, it will give an any back. Make sense? Cool. Yes, you can debug TypeScript in Visual Studio. When I build this, you can turn on something called source maps. Source maps will map all of your JavaScript back into TypeScript. So if you make the source maps available and have them configured correctly, when you go into, for example, Chrome in Developer Tools, when you go into the source, you can go and actually set breakpoints in your TypeScript in the browser. And I do believe that if you do it in IE and you enable types or client-side TypeScript debugging and press F5 in your project, it will attach to IE and it will debug the JavaScript, which has source maps that turns it into TypeScript, so you can debug straight into TypeScript. Yes. Any other questions? Testing. Works fine. Anybody attend my other presentations where I say I hate testing? You would generally transpile it into JavaScript and test it running it in JavaScript, but it works fine. It's basically just JavaScript with a layer on top of it. So you don't test the TypeScript. You have to transpile TypeScript to JavaScript, and then you run those tests. But it's perfectly fine to write unit tests and integration tests in TypeScript, and TypeScript tests your other TypeScript classes. But in the end, it's going to be JavaScript testing JavaScript. Kind of perverse, but yeah, it's possible to do. There was one more hand. Yes. So the question is how I manage different browsers and stuff like I did with the fetch library in this case. So for fetch, there's a polyfill for it. So I would add the fetch polyfill and make sure it's available in all browsers. It's just that I didn't feel like showing that because it didn't make sense for my TypeScript stuff. But in all situations where I go beyond what is in TypeScript, because TypeScript will tell you that this is what's available in your browser and that's it, and then you can go out like I did and tell it I want promises as well. But as soon as you modify what the TypeScript compiler includes, you're responsible for making sure that it's available, because TypeScript couldn't care less. I'm kind of out of time. I will be around if you have any more questions. Don't forget to vote on the way out if you want to give me a green one. If you want to give anything else, then just forget that box outside. Thank you.